Good morning, Nashville. I wanted to provide some further scientific context for the COVID-19 response as we are engaged in currently. And I thought I might share some thoughts from some other pandemics that we had to deal with over the last few decades. The HIV pandemic first arose in 1981, and one of the things that happened at that time was that people felt that this virus only infected gay white men, and that was clearly not the case. From the very beginning, the virus was infecting heterosexual and gay persons, men and women, African American, Hispanic, and white. But that myth took hold and caused a considerable delay in research and developing a national strategy to deal with it. So one of the important lessons that we need to take from that pandemic is how important it is to deal with facts and scientific data when we make our decisions. In the case of COVID-19, there are still those who believe that the virus only affects those who are elderly or have underlying conditions. That's clearly not the case from data from other countries. And as you've heard, here in Nashville, the youngest person that's infected with the virus is 11 years old. So clearly that is a myth that needs to be dispelled and done away with. There's been a lot of discussions about the outbreaks in other countries, comparing those outbreaks to those in the United States here with us. There are some important factors I'd like to illustrate for you that make it important. There are lessons we can learn by doing this. For example, in China, one of the observations that's very interesting is that men are much more likely to get infected, to get really sick, and to die from COVID-19 compared to women. This can probably be explained by behavior and by physiology. Behavior-wise, men all over the world, it's a fact, practice hygiene in a different way, or less meticulous, let's say, than women. And of course, hygiene is an important factor when you're dealing with this virus. The other one is physiology related to the immune system. It's been well established for a long time that women appear to have a stronger immune system than men do. This may be because there are important genes related to the immune system found on the X chromosome. And as you know, women have 2 copies of the X chromosome. Men only have 1 copy. That means that proportionally, women probably have more proteins related to some important immune functions compared to men. But it is clear that there is a disparity in the rate of infection from men and women in China, a very large disparity. And consider this, over half of the men in China smoke compared to less than 3% of the women. And we know that smoking causes changes in the lungs that predispose disease when we get infected by almost any virus. And here in the United States, one of the things that concerns me is teenagers, as you know, have been vaping in large numbers over the last few years. And you might recall that some of the teenagers who vaped got such severe lung disease they had to be hospitalized and treated with a ventilator. So that means that here in this country, we might expect, and there's every reason to expect, that if those teenagers, young people, got infected by this virus, they may get severe lung disease. So that is another factor we need to be aware of. The other thing that I made a point of in my previous conversation with you is that almost anything that compromises the immune system is going to impact the way that our bodies deal with COVID-19. And there are some important conditions that impact the lungs that will do the same. Here in the United States, we still have a large number of people who smoke, and those smokers are known to have changes in their lungs that are going to predispose to disease. So we have to put smokers into the high-risk category. There's also asthma. More than 25 million people here in the United States suffer from asthma. And the pathophysiology of asthma is such that the lungs become inflamed, they get infiltrated with cells from the immune system, and that will compromise their ability to breathe. And importantly, many people with asthma are treated with drugs that suppress the immune system. So in the case of asthma, we have 2 things working against us when it comes to COVID-19. Our lungs are already compromised. We're being treated with drugs that suppress the immune system, making asthma another risk factor for severe disease. And as I said, there are over 25 million Americans who suffer from asthma. The other one I'd like to point out is obesity. Compared to many other countries, the number of Americans who are obese, as you know, is quite a bit higher than other places. And what you may not know is that obesity itself can compromise our ability to breathe, the function of our lungs. For one thing, the muscles that are responsible for expanding and contracting the lungs become compromised in people who are obese. So imagine getting a virus that further compromises our ability to breathe in COVID-19, and you can see that obesity may well be another factor that makes the disease in the United States very different than it is in other countries. The other thing is, I'd like to provide another perspective on the safer at home strategy. I need to talk about something called vectors. Viruses are incomplete life forms with no ability to replicate on their own, so they must find a way to gain entry into the cells in our bodies. And many viruses need hosts before they can jump into our bodies, and those hosts are called vectors. A great example is a parasite that causes malaria. The vector for malaria is mosquitoes. Without getting into mosquitoes, malaria cannot get into our bodies because it's in the blood. The mosquito bites a person, takes up a little bit of blood that has malarial parasites in it, and deposits that into the next person by a microtransfusion when they bite the next person. So in the case of malaria, mosquitoes are the vector. And one of the things that's being done is to literally make the mosquito responsible for malaria extinct. And there's a study in which they're going to try to make the mosquitoes infertile so they'll disappear. In other words, they're trying to eradicate the vector for malaria. Avian flu is another well-known pathogenic virus, pandemic virus that we've been dealing with. And it's one of the most concerning pathogens because it has a 50% fatality rate. That is to say, half of the people who get infected by this flu virus, they die. Thankfully for us, there is no direct human-to-human transmission. We can only get the virus by interacting with the birds that carry the virus. And one of the latest outbreaks, 200 million birds were slaughtered in an attempt to eradicate the outbreak in this particular location. So they eradicated the vector to keep humans protected. Now, in the case of coronaviruses, their normal host are bats. And bats or humans are so genetically distinct that viruses that infect bats cannot infect humans. So there is a requirement for an intermediate host. For SARS in 2002, it was cats. For MERS in 2012, it was camels. And what happens is the virus gets into the intermediate host, adapts to grow in mammals, and then it's able to infect humans. So in the case of SARS, the vector was cats. In the case of MERS, the vector was camels. The difference with COVID-19 is we are the vector, because now that the virus has jumped into humans, it's able to jump from human to human. So in the case of coronavirus that causes COVID-19, we are the vector. So our challenge is to do what was done in the other cases to eradicate the vector. So we're asking you to do, and maybe this can be a hashtag, don't be a vector for COVID-19. Nashville, I'm pleading with you, don't be a vector. And you don't become a vector by staying safe at home, social distancing, sanitizing surfaces often. And if we do that, Nashville, we can defeat this virus. Please, Nashville, don't be a vector. And with that, I'd like to introduce Dr. Lorda Williamson, who is the professor and chair of psychiatry and behavioral sciences at Meharry Medical College.